plastic recycling, closing the loop and defossilising with the Sustainables Academy. Our biosphere has limited resources, all of which could become finite and damage the biosphere depending on how we use them, like earth pollution, depletion of minerals, destruction of habitats, and wasting water. We must become Earth stewards to protect our biosphere. Polymers. There are natural polymers such as silk or wool, or synthetic polymers such as nylon, lycra, spandex, and plastics. Natural fibres can be recycled, but not very easily. But what they can do is biodegrade. Synthetic fibres, on the other hand, can be recycled and kept infinite. Mixing polymers creates a new problem, as splitting them at the end of their life cycle can become very difficult. For circularity, monomaterials are always the best. We also need to think about the life cycle and lifespan. Let's focus on drinks containers and those that can be recycled. Only one of these categories is a consistent monomaterial. Which is it? It's not aluminium cans, as they're made with a plastic lining, and paper and card cartons are also plastic lined, so the plastic bottle is the only one that's a monomaterial. Did you know plastic bottles also create less CO2 when being made than the other two? Let's move on to some questions. In which decade were plastics first manufactured en masse, creating a plastic revolution? The plastic revolution began in earnest in the 1950s. During this decade, the mass production of plastics took off, leading to widespread use in a variety of industries and consumer products. Advances in polymer science and the development of new types of plastics, such as polyethylene and polypropylene, played a significant role in this transformation. How many tons of plastic do you think have ever been created? As of recent estimates, approximately 8.3 billion tons of plastic have been produced globally since the 1950s. This staggering amount includes all types of plastics, used in products ranging from packaging and containers to industrial applications and consumer goods. Is plastic really forever? While plastic is not literally forever, it is extremely durable and persistent in the environment. Most plastics are not biodegradable, meaning they do not break down into natural substances through microbial action. Instead, they break into smaller pieces called microplastics, which can persist in the environment for hundreds to thousands of years. This long-term persistence poses significant environmental challenges, including pollution in oceans, rivers and soil, and potential impacts on wildlife and human health. The circular economy addresses the challenges posed by plastic waste by fundamentally rethinking how materials are used and managed throughout their life cycle. Here are some key ideals. 1. Design for durability, reusability, and recyclability. Durability is creating products that last longer to reduce the need for frequent replacement. Reusability, which is designing products that can be reused multiple times before reaching the end of their life cycle. And recyclability, ensuring that products can be easily recycled and turned into new products, thus keeping materials in use. 2. Promoting recycling and reuse. Efficient recycling systems, developing and optimizing recycling infrastructure to handle plastic waste more effectively. Closed-loop recycling, encouraging the recycling of plastic materials into new products of the same type, reducing the need for virgin materials. Reusability programs, implementing programs and incentives for returning and reusing plastic products, such as refillable containers. 3. Innovative materials and alternatives. Biodegradable plastics, developing plastics that break down more easily in the environment. Or alternative materials, promoting the use of materials other than plastic that have less environmental impact, such as paper, glass, or metal, where appropriate. 4. Extended producer responsibility, or EPR. Producer responsibility, holding manufacturers accountable for the entire life cycle of their products, including take-back schemes, recycling, and proper disposal. Or eco-designs, encouraging producers to design products with minimal environmental impact and ease of recycling in mind. 5. Consumer education and behavioural change. Awareness campaigns, educating consumers about the impact of plastic waste and the benefits of reducing, reusing and recycling. And behavioural incentives, providing incentives for consumers to participate in recycling and reuse programs, such as deposit return schemes for bottles. 6. Policy and regulation. Bans and restrictions, implementing bans on single-use plastics and promoting the use of reusable alternatives. And regulatory frameworks, establishing policies that support the circular economy, such as mandatory recycling targets and eco-labelling. 7. Technological innovation. Advanced recycling technologies, investing in new technologies that can more efficiently recycle plastics, including chemical recycling processes that can handle mixed or contaminated plastics. And smart packaging, developing intelligent packaging solutions that can be easily sorted and recycled. And finally, 8. Collaboration and partnerships. Multi-stakeholder incentives, collaborating among governments, businesses and NGOs to develop and implement circular economy strategies. And global cooperation, addressing plastic pollution through international agreements and coordinated events. Thank you for listening and learning. Find us for more on our website, Instagram, or email us